spanning tree protocol keeps your network stable by preventing loops. It elects a root bridge and blocks redundant paths, ensuring a single logical data flow. But what if an unauthorized device tries to become that root bridge? RootGuard protects your network's design. If a port with RootGuard enabled receives a superior STP message, it shuts down that port to prevent disruptions and maintain network integrity. It's all about keeping your networks predictable and secure. Let's take a look. So let's go ahead and jump into Cisco Modeling Labs. I have my RootGuard lab here ready to go. And if we take a look at it, we'll see there are several different switches, switch 1, switch 2, switch 3, as well as what we're calling an attacker switch. And if we just go ahead and show what the current spanning tree looks like on switch 1, you can see that here. And then we can do the same as well on switch 2, as well as on switch 3. Now take note of the root ID as well too, that address there, DAEF. That might change here in a second because we do not currently have RootGuard enabled. So if we jump over to this attacker switch, let's go ahead and just adjust some of the configuration on it really quick to get started. And we're just gonna go ahead and create a VLAN 1 with priority 0. Then using the topology on the top there, we're gonna create some connections in between the attacker, one connection with switch 2 and another connection here with switch 3. So because we set priority to 0, that's going to tell essentially these other switches that this is the highest priority switches in terms of the spanning tree, and it's going to ultimately take over as the root inside of this particular spanning tree. And we can see that again by running that show spanning tree command again. You can see the address of what is the root has changed. And that's what happens to match the bridge ID of our attacker switch here. So the attacker switch is now taken over as the root of this spanning tree. So how do you prevent this from happening? There's a great capability called RootGuard. Let's go ahead and just show you how to use it. Ultimately, it's going to lock down whatever the root switch is in that spanning tree and prevent a rogue switch from taking over. So I'm gonna go ahead and just get a fresh instance of my lab environment here, and let's select the specific interface that we want to enable RootGuard for. And all you have to do is run this command here, spanning-tree guard root, and you've now enabled RootGuard on that particular interface for that switch. Let's go ahead and do the same thing for our other switches as well and enable it on their interfaces. All right, now we have RootGuard enabled on all 3 switches. Let's go ahead and create those connections again between the attacker switch and switch 2, as well as the attacker switch and switch 3. And if we run the show spanning tree command again on switch 2, you'll see something unique this time. If you take a look at that last interface there, you'll see it's actually blocking any connections through that interface because it noticed that there was an attempt to change the root there. So that root ID is protected. You can see it remains what it originally was. And the attempt by the attacker to override that root and become the root of the spanning tree has been blocked. RootGuard, it's a very, very useful, powerful tool to make sure that you don't have a rogue switch coming in and taking over as the root of your spanning tree. So you can learn more about this and how to implement this on u.cisco.com. Go ahead and check it out today.